Bismillahirrahmanirrahim. Today is the last lecture of this chapter and also the formally the last lecture of this course, which we are studying the automotive technology, and the chapter name is hybrid vehicle. After today's is the last lecture, I have told you I will upload one or two more lecture regarding the automotive technology, but this is formally the last lecture. So let's talk about the basic slide which we are studying, that powertrain or power flow in a conventional rear wheel drive vehicle. We know the engine from where the power is developed, then it goes to the flywheel. From flywheel, it goes to the clutch, gearbox, the transmission. From transmission, it goes to the propeller shaft, and then to the differential box, from where it distributed to the right and the left wheel. These topics which we have covered previously, and the additional topics which we have covered, those are the brakes, suspension, and the steering system, and automatic transmission. Now, the current topic is hybrid vehicle, and today is the last lecture of this topic and last lecture of this course. So, the hybrid vehicles as this is the, as you know, it's my habit to give you a recap of the all the previous lecture of that chapter in the last part. So this is the recap of last two lectures which we have studied. Now, in the background, in the early years of the vehicle development, many different types of propulsion system were used. Those were steam engine powered, gasoline engine powered, and electric motor powered. And in terms which are used in EV vehicles, electric vehicles, or the battery electric vehicles, those are hybrid electric vehicles, zero emission vehicles, fuel cells vehicles, fuel cells hybrid vehicles, proton exchange membrane or polymer electrolyte fuel cell, or plug-in hybrid electric vehicle. A brief introduction to the hybrid vehicle. A hybrid vehicle is one that uses two different methods to propel the vehicle. A hybrid electric vehicle, abbreviated HEV, uses both an internal combustion engine and an electric motor to propel the vehicle. And the most hybrid vehicle uses a high voltage battery pack, the other source, and the combination of electric motor and generator to help or assist a gasoline engine. So this was the brief introduction of a hybrid vehicle. Though these are different configurations of hybrid electric vehicle, we have a hybrid electric vehicle, then plug-in hybrid electric vehicle, and the battery electric vehicle, and we have studied this thing. Now, the electric vehicle, early electric vehicle, you are using the lead acid batteries and electric traction motor and mechanical controller. Those that were the proof or initial technology. Later on, the development with the development of the technology and the advancement in the battery techniques, so different phases has been occurred. So this was the general layout of an hybrid electric vehicle. We have an engine on the front, and then we have a battery bank on the trunk or in the rear, or beneath the rear seat. And this is like this. Then driving a hybrid vehicle, some unique characteristics that has to be followed by the driver, how it will have to operate the hybrid electric vehicle, because the driving is little bit different than a conventional vehicle. So we have studied these techniques or characteristics which the driver may or may not include or notice. This was the first portion of this chapter. Now, in second portion, we have studied the classification of a hybrid electric vehicles. And in this, we have studied the four classification: the series hybrid, parallel hybrid, series parallel hybrid, and belt alternator starter system. In first, the series hybrid, the engine solely charges the battery while the electric motor drives the vehicle. So we have studied the advantage and disadvantage. So the simplest is the energy solely charges the battery while the electric motor drives the vehicle. So this was like this, and the main diagram was this, like I explain again. We have an engine, and then power goes to the generator. From that generator, the power goes to the inverter. And from batteries, it is also coming to the inverter. From inverter, it goes to the motor, and motor drives the reduction gear and the drive wheels. So this is how the power flow in a series hybrid vehicle is. And this is the elaborated diagram of a series hybrid, which we have studied in our second part. Now, in second part, the parallel hybrid uses both the engine and electric motor to power the vehicle simultaneously. So they are simultaneously propelling the vehicle with the help of electric motor and internal combustion engine. So few advantages and disadvantages. And in the parallel hybrid design, multiple propulsion sources can be combined, or one of the energy source alone can drive the vehicle. So it is either both or either one simultaneously we can use in a parallel hybrid combination. So in this design, the battery and engine are both connected to the transmission. Let's see the figure. So the simplest figure, we have an engine, then we have a transmission, and power is going to the reduction gear and the drive wheel. And from batteries, it is coming to the inverter. From inverter, it is coming to the motor or generator. And from that generator, it is going to the reduction gear and then to the wheel. So this is the simplest parallel hybrid system. So this is the elaborated diagram of the parallel hybrid system which we have studied. Now the third one was the series parallel hybrid system, which is most commonly used nowadays. They can operate using the electric motor power alone or with the assist of the internal combustion engine. Series parallel hybrid combines the function of both a series and a parallel design. So in the internal combustion engine may be operating even though the vehicle is stopped if the electric controller has detected that the batteries need to be charged. So if your battery needs to be charged, even when your vehicle is stopped, the internal combustion engine is working because it is charging the batteries. So the simplest diagram for this series parallel hybrid was we have an engine. From engine, we have a power split device. From power split device, there are two passages. One is going to the generator and one is going to the reduction gear and then to the drive wheel. And from that other path going to the generator from that going to the inverter. From inverter, it is going to the motor, and from motor is driving the reduction gear and then to the wheel. So this was the simplest diagram for a series parallel hybrid vehicle. Now the fourth one, that was the bus, the belt alternator starter system. The BAS concept is to replace the belt-driven alternator with an electric motor that serves as a generator and a motor. When the engine is running, the motor acting as a generator, it will charge a separate 36-volt battery, 42-volt charging voltage. When the engine needs to be started again after the engine has been stopped at idle to save fuel, idle stop, the BAS, the belt alternator starter system motor is used to crank the engine by taking electrical power from that 6-volt battery pack and applies its torque via the accessory belts and cranks the engine instead of using the starter motor. The BAS system uses a conventional starter motor for starting the ICE engine. The first time it ends only uses the high voltage motor generator to start the internal combustion engine while leaving the idle stop mode. So this was the simplest configuration of a belt alternator starter system. And then the vehicle speed with respect to the time chart, we have studied this. What action is with respect to time is happening at that vehicle speed. Now, the common features of most hybrid vehicles, these are the common feature which we have studied in our second part, the idle stop, what is happening at the idle stop, and then the regenerative braking, how the inertia is converted into electrical energy. Then the power assist, the internal combustion engine during acceleration, the power assist, and the engine off, drive electric vehicle mode, motoring mode basically. And then this is a slight different topic. What is the difference between hybrid electric vehicles and plug-in hybrid electric vehicles? So we have define this difference with respect to the five characteristics. One was the power source, then was the electric only drive range, and fuel economy, charging, and cost. With the help of these, we have tried to develop the difference and what is the difference between the hybrid electric vehicles and plug-in hybrid electric vehicles. This was up till the last two parts which we have covered in this chapter. Now of uh, today's topic of lecture is level of hybrids vehicles. So basically, there are three levels of hybrid vehicles. One is mild hybrid, second is medium hybrid, and full hybrid. Now, first one, the level of hybrid vehicle. The first one, the mild hybrid. A mild hybrid will incorporate idle stop and regenerative braking, but is not capable of using the electric motor to propel the vehicle on its own without help from the internal combustion engine. So mild hybrid is the smallest or the least hybrid in which it will incorporate the idle stop and regenerative braking. So these are the two characteristics which will incorporate it, but it is not capable of using the electric motor to propel the vehicle on its own. So it cannot move it on its own by the use of this electric motor without the help from the internal combustion engine. A mild hybrid system has the advantage of costing less but saves less fuel compared to a full hybrid vehicle and usually uses 42 volts electrical motor and battery package, 36 volt batteries, 42 volts charging. An example of this types of hybrid is General Motors Silverado pickup trucks and Saturn BUE. The fuel saving for a mild type of a hybrid design is about 8 to 15%. So a mild hybrid system has an advantage of costing less because less complex circuits are involved there, less equipment are involved there. So it's cost less, but save less fuel. So it save very less fuel as compared because it is a simplest form compared to a fully hybrid vehicle, which is having a complex nature. Usually uses 42 electric volt motor and a battery pack, 36 volt batteries, 42 volt charging. An example of this type of hybrid is General Motors Silverado pickup truck and the Saturn VUE. The fuel saving for a mild type of a hybrid design is about 8 to 15%. So the fuel saving in this type of a hybrid design, that is mild hybrid, is 8 to 15%. The electric motor assists the engine but cannot solely power the vehicle. So advantages of a mild hybrid vehicle classification is improve the fuel efficiency and reduce emissions. Regenerative braking helps charge the battery, and disadvantages are limited electric power capability, minimal impact on overall fuel consumption compared to other hybrid. So these are the disadvantage of a mild hybrid vehicle. Now coming towards the second the second level of hybrid vehicles, that is the medium hybrid. A medium hybrid uses 144 to 154 volts batteries that provides for engine stop, leak start, regenerative braking, and power assist. So in this medium hybrid uses 144 to 158 volts batteries that provides for engine stop, leak start, regenerative braking, and power assist. Like a mild hybrid, a typical medium hybrid is not capable of propelling the vehicle from a stop using the battery's power alone. So like a mild hybrid in which we only batteries alone cannot propel the vehicle, it's always require an internal combustion engine. Almost same goes for the typical medium hybrid that is not capable of propelling the vehicle from a stop using battery power alone. Example of the medium hybrid vehicle includes the Honda Insight, Civic, and Accord. The fuel economy saving are about 20 to 25% of for a medium hybrid system. In a mild system, we were having 8 to 15% economy, but in medium hybrid, we are having a fuel economy saving is from 20 to 25%. Now, the level of hybrid vehicles is the full hybrid vehicle. A fully hybrid vehicle, also called a strong hybrid, uses idle stop, regenerative braking, and is able to propel the vehicle using the electric motors alone. So, in this full hybrid system or in this level of hybrid, it can alone propel the vehicle with the help of using electric motors. A full hybrid, also called a strong hybrid, uses idle stop, regenerative braking, and is able to propel the vehicle using the electric motors alone. Each vehicle manufacturer has made its decision on which type of hybrid is to be implemented based on its assessment of the market Nike for a particular model. Example of a full or strong hybrid includes Ford Escape SUV, Toyota Highlanders, Lexus RX 400h, Lexus GS 450h, Toyota Prius, Toyota Camry, and so many more. The fuel economy saving are about 30 to 50% for a full hybrid system. So the fuel economy saving in which we are full hybrid system is 30 to 50%. Now, the fully hybrid offers electric only driving at a low speed and a combination of engine and electric power at a high speed. At a low speed, electric driven at a low speed, but at a high speed, the combination of engine electric motor power at a high speed. Advantages of a fully hybrid system: higher fuel efficiency compared to traditional cars or the rest of the levels. Regenerative braking and automatic engine shuts off enhance efficiency. So regenerative braking, the braking power is with the help of inertia, which we are getting from the applying the brakes from your wheels. So that regenerative braking and the automatic engine shuts off enhance efficiency. Disadvantages: typically more expensive than mild, medium, and other hybrid unconventional cars. Limited electric only range. Please note that advantages and disadvantages can vary depending on the specific model and technology implemented in each hybrid car. So we have to see that the advantages and disadvantages can vary depending upon the specific model or specific technology implemented in each hybrid car. Now, the plug-in hybrid electric vehicle, we have covered this thing, but to give you more knowledge on this, similar to parallel hybrids, but with the larger batteries that can be charged from an external power source. So these batteries can be charged from an external power source. That's why they are known as plug-in hybrid electric vehicles. The advantages: longer electricity only range, reducing the need for a fuel, lower emission and better fuel economy when driving in electric mode. Disadvantages for plug-in hybrid electric vehicle: higher initial cost due to larger batteries, limited charging facilities in the you know, limited charging infrastructure available for this type of vehicles. Now, the frequently asked questions: is a diesel hybrid electric vehicle possible? Yes. Using a diesel engine instead of a gasoline engine in a hybrid electric vehicle is possible, while the increased efficiency of a diesel engine would increase fuel economy. The extra cost of the diesel engine is the major reason that this combination is not currently in production. Technically, it is possible and it was tried, but due to the economic factor, it is not in production. What is an assist hybrid? An assist hybrid electric vehicle is term used to describe a vehicle where the electric motor is not able to start moving the vehicle on electric power alone. So this method of hybrid will include all mild hybrid 36 to 40 volts as well as the medium hybrids that uses 144 to 154 8 volt system. What is an assist hybrid? An assist hybrid electric vehicle is a term used to describe a vehicle where the electric motor is not able to start moving the vehicle on electric power alone. This type of hybrid would include all mild hybrids, 36 to 42 volts, as well as the medium hybrid that uses 144 to 158 volt system. Now, there are some high safety features or service procedure which we have to be followed. High voltage safety. Hybrid electric vehicles and all electric vehicles uses high voltage HV circuits that if touched with an unprotected hand could cause serious burns or even health death. So high voltage safety you have to cater for, you have to take in account, you have to very cautious because the hybrid electric vehicles and all electric vehicles uses high voltage HV circuits that if touched with an unprotected hand could cause serious burns or even death. Identifying the high voltage circuits. How to identify the high voltage circuit in a hybrid vehicle? The high voltage cables are identified by a color of plastic conduit and includes by the color coding we can identify blue or yellow. It contains 42 volts, not a shock hazard, but an arc will be maintained if a circuit is open. So if you having a blue or yellow plastic conduit on a wire, so it contains 42 volts, not a shock hazard, but an arc will be maintained if a circuit is open. If we have a color coding of orange, that is 144 to 600 volt or higher, so it is very dangerous. So be very careful regarding the orange plastic conduits or colored or any other electric, but be very careful. Then jump starting. This hybrid safety and service procedure. The second is jump starting. The 12-volt auxiliary battery may be jump started if the vehicle does not start. So we can use a 12-volt auxiliary battery for a jump start if the vehicle does not start. The 12-volt auxiliary batteries is located under the hood or in the cargo trunk area of some hybrid electric vehicles or depending upon the location by the OEM. Using a jump box or jumper cable from another vehicle makes the connection to the positive and negative battery terminal. So how it look like? We have this vehicle. This is the rescue battery. The positive terminal is connected to the positive terminal, and negative terminal is connected to the body of the vehicle or giving earth to the connector. So jump starting this type of Toyota Prius using a 12-volt supply to boost the 12-volt auxiliary battery in a trunk. Basically, here is the circuit and this red portion. Now, the this under this hood, we have this 12-volt start terminal on this Toyota. The under the hood, we have this red portion, 12-volt jump start terminal on this Toyota Prius as a red plastic cover with this sign. The positive booster cable will be connected here with this bracket to start the vehicle. Now, the other feature which we have to take into the account that is hybrid safety and service procedure, towing. If a disabled vehicle needs to be moved for a short distance to the side of the road, for example, and the vehicle can still roll on the ground, the easiest way is to shift transmission into neutral and manually push the vehicle. So if your vehicle is disabled and needs to be moved for a shorter distance, means to the side of the road, for example, and the vehicle can still roll on the ground, the easiest way is to shift the transmission into neutral. So the position of the lever of your automatic transmission will have lever, the shift lever we have to be in the neutral position and manually push the vehicle. To transport the vehicle away from an emergency location, a flatbed truck used should be used if the vehicle might be repaired. If a flatbed is not available, the vehicle should be towed by a wheel lifting equipment with the front wheels off the ground. Forward wheel driven hybrid electric vehicles only do not use sling type towing equipment. So mostly the hybrid vehicles are front wheel driven. So when your vehicle are having any problem, it cannot be moved. You have to lift the front wheels so in such a manner that they are not in contact with the ground, and on the rear wheels you can move them, or with the help of some wheel lifting equipment you have to move that vehicle. Now another interesting subtopic is the fuel cell technology. In the first slide we have talk about different PHVs, fuel cells, proton polymers, and what is now the fuel cell technology. What is a fuel cell? A fuel cell is an electrochemical device in which the chemical energy of a hydrogen and oxygen is converted into electrical energy. A fuel cell is an electrochemical device in which the chemical energy of hydrogen and oxygen is converted into electrical energy. The principle of a fuel cell was first discovered in 1839, more than almost 200 years ago, by Sir William Groove, a Welsh physician. The chemical reaction in a fuel cell is opposite of electrolysis. It is important to note that while hydrogen can be used as a fuel, it is not an energy source. Hydrogen can be used as a force, but it is fuel. Hydrogen can be used as a fuel, but remember that it is not an energy source. Instead, hydrogen is only an energy carrier, as energy must be expended to generate the hydrogen and store it so it can be used as fuel. So the chemical reaction in the fuel cell is opposite of the electrolysis which is happening in the lead acid batteries or in any electrolysis process. It is important to note that while hydrogen can be used as a fuel, it is not an energy source. Instead, hydrogen is only an energy carrier, as energy must be expended to generate the hydrogen and store it so it can be used as a fuel. In simple terms, a fuel cell is a hydrogen powered battery. In simple terms, a fuel cell is a hydrogen powered battery. Hydrogen is an excellent fuel because it has a very high specific energy. Hydrogen is an excellent fuel because it has a very high specific energy when compared to an equivalent amount of fossil fuel. When compared to an equivalent amount of fossil fuel. 1 kilogram of a hydrogen has 3 times the energy contents as 1 kilogram of a gasoline. So it is 1:3. 1 kilogram of a hydrogen contains as much energy contents as 3 kilograms of uh, gasoline engine. Hydrogen is the most abundant element on Earth, but it does not exist by itself in nature because it always in combination with some other form. So it is most abundant element on the Earth, but it does not exist by itself in nature. Now, the some of the challenges which fuel cells technology have, it is a new, so it has a high cost, lack of refueling infrastructure, safety perceptions are there, insufficient vehicle range, lack of durability, freezing starting problem, insufficient power density. So these are the few challenges which are faced by the fuel cells. Those are high cost, lack of refueling infrastructure, safety perceptions, insufficient vehicle range, lack of durability, freezing starting point problem, insufficient power density. And the assignment for you people is to study these in details. So this was the last lecture of this course of automotive technology. uh, one or two short lectures on the automotive technology I will may be uploading in the next days to come. So thank you very much for listening and understanding. And if you have any question, please ask freely ask me on my email address, or you can inbox me like this. Thank you very much.